So please give him a warm welcome.
Thanks very much. My name is Matt Chaput. I'm a technical writer, graphic designer, and UI designer, many hats, at Side Effects Software. Self-taught programmer, which is good because the developers, even though I work for a software company, the developers don't always have time to write the tools that I need to support, sort of the online help infrastructure. So I can write it myself in Python because it's fun. And I am a bit of a dilettante in the computer science field of information retrieval. I probably know more than a lot of people because I read the books and the papers and try to understand them. But if you are a computer scientist in the field of information retrieval, I will seem incredibly dumb to you. I'm an English major, so when I read these papers and I see, yes, thank you. When I see sigma notation in math, I heave a heavy sigh. Side Effects Software makes Houdini, a high-end 3D animation and special effects package similar to Maya, Softimage, 3D Studio Max, some of our competitors. We're the only one that's not owned by Autodesk nowadays. Used in films, games, commercials, basically high-end CGI. We've won 2 Oscars, which doesn't suck. And it uses Python as its scripting language. So when we wanted to make the online help searchable, it made sense to write a search engine in Python. Before Python was shipped with the product, I wrote a little hack using Java Lucene as a background process to try and make the help searchable. Customers hated having to install Java, no matter what we told them or tried how easy we tried to make it. It didn't help that back then, at least, we couldn't ship Java just as a component of the software. We actually had to force the users to install it separately because of legal issues with Sun. So it was a big hassle. Why didn't we just use one of the existing C or C++ libraries or something? People smarter than me tried to integrate them into our build process. But I don't know if it's just me or this is a general thing, but I think I admit some kind of field that destroys installers and makes compiled software dump core. I've never gotten the Lucene Python bindings to work. I've never gotten PIL to work on any OS on any computer. So it might just have been my presence, but we couldn't get any of the existing solutions to sort of compile and run robustly. And we had Python, and you write it in pure Python, it works where Python works. So I told somebody the other day, I got 99 problems with Whoosh, but make install ain't one. So I wrote a search library, and we used it in Houdini to make this help searchable. And I started to wonder if it would be useful to anybody else. The use case I had in mind was Moin Moin, was shipping with a sort of ancient, unmaintained port of Lucene to Python. And I thought if I could make Whoosh useful enough, maybe at least one other project would get some use out of it. So in 2007, I got permission to open source it. It hit the front page of Hacker News for some reason I don't understand. Mostly, I think, novelty, and they were making fun of it. Because it was pretty slow. It was a lot faster than the sort of hack I'd been using with SQLite as a backend, so it seemed fast to me. But, I mean, it wasn't exactly Google. It still isn't exactly Google, but it's a lot faster now. I mean, people always want to talk about extreme document sets of, tens of millions of documents and indexing the web. Whoosh won't do that, but I think there are a lot of interesting applications that are, fewer than 1 million documents, fewer than 1,000 searches per second, where there are benefits to using a pure Python solution, and Whoosh is cool at that. Who's using Whoosh right now? Houdini, obviously. Moin has switched to using Whoosh to make the wiki searchable out of the box. There's a project called Django Haystack, which makes Django sites searchable. They let you plug in Solr or Zapier or Elasticsearch, I believe. But to make it work out of the box without having to compile anything or install these sort of libraries in other languages, they use Whoosh as the default. So it's cool that it's able to do that for them. And I have lots of users on Bitbucket and an active mailing list full of users who are cool and intelligent and nice and presumably very good looking. So it's a programming library. It's not a server like Elasticsearch or Solr. Basically, you just import it and call the API. It's a toolkit for building your own search engine, basically. It has all the parts you need, and you just wire them together by scripting Python. It doesn't have a web crawler. You basically have to have all your text that you want to index in a string for each field, for each document, and pass it to the index function. You can, of course, write your own code or use it to pull text out of files, or you hook up a web crawler, but it's not part of Whoosh's code. It's thread and multiprocess safe. It's under a 2-clause BSD license, so it's GPL compatible. And it's compatible with Python 2.5 and later, including Python 3. It has a lot of features that I don't have time to talk about, unfortunately. Basically, just anything that Lucene or Zapier or Solr can do, Whoosh can do, just maybe not as fast when you're talking about huge document sets. So an inverted index, for anyone who doesn't know, basically takes all the words from the documents you index, processes the terms, which are usually analogous to words, but not always. For example, you can remove words that are too common to index, called stop words. You can remove suffixes like ing and ed, that's called stemming. Then do a big, huge sort, which is the slowest part. And what you get out is a mapping from terms to what's called a posting list of all the documents that term appears in. And each posting can have metadata such as what positions the word appeared in that document, so you can do phrase searching. That's basically what I just said. And then when you want to search, you use the query parser in Whoosh to parse the user's query string. Run the search, and that's when you can do, say you want to group the results by certain fields, you want to sort by a certain field, you want to get page n of m, and then once you get a results object, you can use that to do spelling corrections. The results object acts like a list of hit objects. Hit objects give you all the stored fields for the documents that matched, and they have useful methods for doing things like getting highlighted snippets from the document showing what matched in the document, and doing things like more like this, which isn't really a big thing, seems like, these days in search results UI, but you can do it. So the first thing you do when you create an index for the first time is you define a schema. It's actually under the covers, a lot like Lucene, where you don't need a schema, but I find that enforcing a schema, making people list the fields that they're going to use and the field type associated with that field name, makes it a lot easier when you're using the API, because you don't have to constantly pass in the information about the field when you want to use the field, and make sure that it's the same every time. So we just store it in this schema object, pickle it with the index, and so once you've done it once, every time you load the index, it just knows about all your fields. To index, you basically just get a writer object from your index and call writer.addDocument, where the keyword arguments, the keys are field names and the values are the text you want to index in each field. And when you want to search, you get a searcher object from your index, and, well, first you parse your query, get a searcher object, call search on it with the query, and you get a results object. And then you can just pull hits out of that and pull stored information out of each hit. Have a lot of cool query types, all the ones you would probably expect, simple terms and or not, booleans, nested queries, phrase, near, contains, ranges, wildcards, fuzzy matches. And I will show you this fake search page that I made where I indexed the Python help, so that if you search for the email modules or just the word email or mentions of the word heap that are not in the heap queue module documentation. You can also search individual fields, like find all the pages that have XML RPC only in the title. I mean, not only in the title, but only search the title. I've made a bunch of fields in this index, like references to modules. So you can find pages that refer to hashlib, but aren't in hashlib. Phrase searches. The date parser. So I have the revision dates, last revision dates that I pulled out of Mercurial, so I can find all the pages that were last revised in 2010 or this year, or from 2 years ago to now. And I've got the revisions in a numeric field, so I can just search for all the revisions, all the pages that are in revisions from like 70,000 to 75,000. So I've just got it set up with a simple AJAX call that every time I change this field, it's going to run the search again. But it's not quite like you would see in iTunes, because as you can see, if I don't type a full term that's in the index, it doesn't return anything. It just thinks I'm searching for this word documi that isn't a word. If I want to do iTunes-like searching, instead I'll use an n-gram field. For those people who aren't familiar with this, basically, instead of indexing the text as if it's a bunch of words, for example, the word hello, instead of indexing that as one word hello, you index it as HE, HEL, HELL, EL, ELL, all the 2, 3, 4, however many character windows, all along the string. And what that gives you, did I save that? Is now when I search for if you can see the query representation, it's searching for this in this title grams field for the sort of the same windows along. So it will find things for these partial searches. So it gives you that cool iTunes-esque search as you type UI. Thank you. Show you highlighted search results, search snippets for, say, the first 10 results in every search. So now when I type message, I see where message matched in each document. This is pretty standard stuff from Google, but it's cool. You can see the stemming where this field is set up to remove suffixes. So if I type messages or messaging or messaged, it's going to match all the instances of every word that has message as the root word. Even if you type something meaningless like messagation, it's just gonna, the thing about stemming, it's just gonna take, it's just a computer, it's just gonna take off whatever looks like a suffix. If you wanted to make something like that not, if you are designing this user experience and you want to make that not match anything, then you could index both stemmed and unstemmed versions of every word and do some magic that if exactly what the user typed isn't in the index, then in an unstemmed form, then don't show them any stemmed results. So when you're deciding how to sort of extract terms, filter them, what analyzer you run on the query can be different from the one you run on the text when you index it. It's kind of how you design the experience. It's like UI design of what's findable and how the users are able to sort of type in what they want to find. Also, we have spelling corrections. So I think that Whoosh might be the only pure Python spelling correction spell checking library, as well as pure Python search library. So if I type basically make typos, it's gonna, I've got a little did you mean, and it'll highlight its suggestions for words that didn't match anything based on the words in the index. It's not completely intelligent because if you we can recognize the Von instead of Van as a misspelling, but Von is in the index, so it won't be flagged as a misspelling. You could get clever with this with byword fields so that you knew that Guido is usually followed by Van and not Von. I haven't done that for this demo, but I think it's an interesting sort of avenue that I hope to work on someday. I know that a lot of other people or projects have this kind of thing. I would like to try implementing it in Whoosh in Python. Can do sorting. So I'll sort by the title in reverse. It can do search by, or sort by any field, sort by multiple fields. You can also do grouping. Unfortunately, I didn't have time to make this look good on the page, but if I group by chapter and type something, you can see that as part of the results object, it gave me this dictionary where the keys are values from the chapter field, and the values are lists of document numbers that were in that, that had that value for that field. So hopefully it's clear, I don't know, but if with a little more work on this template, I could go through every key and use the document numbers to show the results, so that I would have like a heading that was the chapter name, and then all the results from that chapter under that heading, so sort of grouping the results. Or just at the top, tell people that, you know, in this chapter there are 50 results, in this chapter there are 10 results. You know, it's just a way to do useful search UIs. Whoosh has some pretty advanced features. A lot of them are similar to features in Lucene and Solr. I support using the multiprocessing module to speed up indexing when you have a lot of processors, sorting and grouping. The object that collects the results, you can replace that with a custom collector to do things like tell you which of all the queries, of all the sub-queries in your query, which ones matched and which ones didn't match. Hierarchical searching, where like if you have albums as a document and each song on that album as sub-documents, you can do queries like tell me all the albums that have songs with foo in the title. Or conversely, tell me all the songs with foo in the title that are part of albums with bar in the title. So that's something that I've added, and I'm hoping to play with more and expand and make easier to use soon. The faceting and sorting stores values for each field in a sort of columnar, like a column-based database format, and you can plug in custom column types where, like, if you know that the values of a certain field will always increase, you can store the numbers as deltas instead of the whole number to save yourself some space. And codecs are basically an idea I stole from Lucene, where all the sort of interaction with the API goes through a really low-level replaceable or wrappable layer, so that you can completely change the backend or the storage format, or, you know, basically anything, and all the higher levels of the API don't need to know about that. They will just work. I think there are some advantages to having this search engine library in pure Python, even though it seems strange and it's not quite as blazing fast as it would be in Java or C++. First of all, it's fun to work on for me. And, you know, it just works. It's easy to iterate fast when you're sort of designing how these fields should look. And you can just start up the interpreter and inspect the index, try things. And it's easy to integrate with other Python code. I won't talk about what's bad about it, because that would be negative and I'm already out of time. And future directions, just some ideas for things that I want to work on. If you check the slides, it'll be there. One of the things is it's a huge code base at this point, and there's a lot of interesting code that I think would be useful to split out into sub-projects so that they're on PyPy if anybody wants to use them without having to download Whoosh. And so here are some resources if you get the slides to find out more. And thank you very much.
All right, thank you very much. Unfortunately, since the lightning talks are